Yeah, please go ahead. What are your questions?
Ma'am, practice assignment question from week 12.
Okay, let me open the. Okay. When is your exam scheduled?
Ma'am, one Sept.
Oh, so so okay. It's on Sunday, right?
Yes, ma'am.
Right. Yeah, week 12, right?
Yes, ma'am.
Week 12. Okay, which assignment? Practice
Ma'am,
assignment.
practice assignment question 10.
Okay. Okay, I think I have it. So just correct me if I'm writing the wrong question, but as far as I see in my assignments record, this is the question. I hope my screen is visible.
Yes, ma'am.
So you're supposed to find the inverse Laplace transform of the following. Is that the question?
Yes, ma'am.
All right. So could you tell me like what is the difficulty that you experienced with this question, or would you just like me to solve this problem?
Ma'am, it would be better if you just solved it. Ma'am, the difficulty is the bottom part, the s cube plus 7s square. How do we, if I'm factorizing this, how do we solve this?
Mm. So understood. So mm, usually, you won't be asked to factorize such harder equations in your exams. But since this is an assignment kind of problem, you can just try to find the roots of this expression by just equating it to zero, because you are doing it at your homes. You have the tool set, so you just try to find the roots of this thing. Okay, and you can find it out easily that the roots are minus 3, minus 2, minus 2 when you solve for this expression. Okay, if you have a mathematical calculator in hand, you can just plug in this equation and you can find the roots of this expression. Okay, or there's also another simple way to see this. You can just factor certain things out and see like the roots. So s cube plus 7 s squared plus 16 s plus 12. This is just simply s plus 3 times s plus 2 whole square. Okay, and when you are given some questions like where f of it is some function x of s times e power minus some as, uh, we know like how to do an inverse Fourier transform for this using the properties of inverse Laplace transform of this part by using the properties of the Laplace transform. When we have an exponential function in front of the actual Laplace transform, we know how to do the inverse Laplace transform. That is the property of the Laplace transform, right? From the properties of Laplace transform. So in such cases, it's always better to first try to find the inverse for this function. Like in this case, this f of s can be divided into x of s times e power minus 3s, split the exponential term and write the other part. And now x of s is simply 3 times s plus 4 divided by s plus 3 times s plus 2 square. So first try to find the Laplace transform for this thing. And what is the Laplace transform for this thing? I mean, using the properties of Laplace transform, when you apply the inverse Laplace transform, this will have f of t, right? F of t would be simply x of t minus 3, right? By x of t minus 3 has Laplace transform e power minus 3s times x of s, right? So when you take the inverse Laplace transform, f of t is simply x of t minus 3, where x of t is the Laplace transform, inverse Laplace transform of x of s. So let's try to find what x of t is. So let's try to find the IFT inverse, ILT inverse Laplace transform for this function. So ILT of this. So how do we find that? Remember, when you have something like this, always write it in terms of s plus 3 times s plus 2 square. Always try to represent it in terms of the fraction of variables. How do we write the fraction of variables? So this is how we write the fraction of variables and equate the expressions. So 3 times s plus 4 is equal to a times s plus 2 square plus b times s plus 2 times s plus 3 plus c times s plus 3. When you try to equate them, what you get is, this is something that I have already done, so you guys can also try to do. So a is 3, b is minus 3, and c is 6. Okay, so writing in terms of the fraction of variables, x of s is simply 3 by s plus 3 minus 3 by s plus 2 plus 6 by s plus 2 whole square. Now, since the Laplace transform is linear, its inverse Laplace transform is also linear. So, ILT of x of s is x of t, which is simply the inverse Laplace transform, 3 times the inverse Laplace transform of 1 by s plus 3 minus 3 times the inverse Laplace transform of 1 by s plus 2 plus 6 times the inverse Laplace transform of 1 by s plus 2 square, right? And what are these things? So we know that this is 3 times e power minus 3t u of t, right? And minus 3 times e power minus 2t u of t, and plus 6 times t e power minus 2t u of t, right? So this is the inverse Laplace transform. In other words, this is your x of t. Now how do we find f of t? F of t is x of t minus 3. So we know x of t. F of t is simply x of t minus 3. Is that okay?
Yes, ma'am.
Yeah. So when you see something like exponential in the given problem, always try to relate it with the properties of the Laplace transform that we already know. So, uh, yeah. So x of s e power minus 3 is, when you try to relate it with the properties, what you get to see is f of t is x of t minus 3. So it is sufficient to find the inverse Laplace transform of x of s. And we do that by this fraction of variables method, and we get the nice expression for x of t, and using that we try to find f of t. Okay.
Yes, ma'am.
Mm.
Graded question 3.
It's again in week 12.
Yes, ma'am.
Okay, give me a second, let me open week 12 graded question 3. Okay, so h of s is given as s square plus 5s plus 8 divided by s plus 2, where the ROC is given as a real part of s is greater than minus 2. Now you're supposed to find the inverse Laplace transform. So how do we go with this? So you can write h of s as, so this, as you can see, is s plus 3 times s plus 2 divided by s plus 2 plus 2. Okay, so I mean, you have s square plus 5s plus 8 is equal to s square plus 5s plus 6 plus 2, and this you can write as s plus 2 times s plus 3 plus 2. Hence we have h of s is equal to s plus 2 s plus 3 plus 2 by s plus 2, and what you have is s plus 3 plus 2 by s plus 2. And from here we know, right? So h of t is inverse Laplace transform of s plus 3 times inverse Laplace transform of 1 plus 2 times inverse Laplace transform of 1 by s plus 2. Since the ROC is right side of the rightmost pole, the given function should be a right-sided function. Hence this is 2 times e power minus 2t u of t, and inverse Laplace transform of 1, we know that it is del of t. Inverse Laplace transform of this, we know that that is d by dt of del of t, right? So the final h of t expression could be d by dt of del of t plus 3 times del of t plus 2 times e power minus 2t u of t. You have to be little careful here. When you have 1 by s plus a, if the ROC is greater than minus a, then this is e power minus at u of t. Okay. Or if you have the other thing, 1 by s plus a, if the real part of s is less than minus a, then I think the ROC should be the left-sided signal. So e power minus at u of minus t. So you have to be very careful with these things. Check for the region of convergence when you're trying to invert some things like 1 by s plus a. If the given ROC in the right side of the uh, you know rightmost pole, then the signal should be right-sided function. Hence, it should have u of t function. If it is left side to the leftmost pole, then it is a left-sided function. It should have u of minus t uh, when you try to invert it. Okay, have to be little careful with these things. But yeah, otherwise I hope this question is clear.
Yes, ma'am. Ma'am, in question 7, I'm getting the wrong option. Ma'am, I'm getting u of 3 e power 3t u of t. The answer is given as 3 e power 3t u of minus t. Can you please check the answer?
Mm, okay, so the given system is stable. What do we mean by the? So let's try to analyze this. Okay, so so it's question 7, right, or 8?
Ma'am, question 7.
So question 7, uh, h of s, correct me if I'm wrong. So h of 7 is that correct?
Yes, ma'am.
And what are your poles? So poles are s equal to 3 and s equal to minus 5. So let's plot the pole 0 plot. We have sigma, we have j omega. Poles are at 3 and minus 5, correct?
Yes, ma'am.
And if the system should be stable, what does that mean? The ROC
Should have j omega axis.
should contain j omega axis. Okay, so which implies the ROC is real part of S should be greater than minus 5. So real part of S will lie between. Okay, this is the ROC. So when you have this as the ROC, how do you go with this? So 3 by S minus 3 inverse Laplace transform of 1 by S minus 3 is what? E power 3t u of minus t. Think there's also a minus over here. Will there be? But I think this is clear, right? What was your question? Sorry, what was your question?
Ma'am, I don't understand why there is u of minus t.
Oh, why there is u of minus t? There is u of minus t because, as what I said earlier, so 1 by s plus a, okay, or if you take 1 by s minus a, uh, I think the inverse Laplace transform. I don't have my notes exactly here now, but you may have found the inverse Laplace transform for minus e of at u of minus t and e of at u of t. What are the Laplace transforms here?
Uh, do these two have same Laplace transform?
They both have the same Laplace transform, but the region of convergence is different. That's what I told you earlier. You have to be very careful with the region of convergence. So this signal is a right-sided signal. So what is the Laplace transform? Let's calculate. So from minus infinity to infinity, e of at, u of t. What is this? E power minus st, right?
Yes, ma'am.
E power st or e power minus st?
Minus st.
Okay. So when you evaluate this, what happens? So this is from 0 to infinity. E power uh, a minus st. No, I think.
It is 1 upon s minus a only, I believe.
No, I think for the Laplace transform, shouldn't this be e power st? No. So, sorry, I'm just confused with the definition of the Laplace transform. What is the definition of Laplace transform? E power minus infinity to infinity x of t.
I
Minus
believe it
estimate.
is, yeah, minus st only.
Okay. E power minus st dt. Okay. So, uh, all right. So when you try to do that for this particular problem, so what happens is this is 0 to infinity e power a plus a minus s t dt, which is minus 1 over a minus s e power a um, minus s minus a t in the interval 0 to infinity, which is simply 1 by s minus a. Correct? And since this is a right sided signal, this is a right sided signal, right? Remember, I have told in the earlier live sessions for the right sided signal, the ROC should be right side to the rightmost plane. Hence, the ROC would be real part of s greater than a, right? Why? The pole is at A and the given signal is a right sided signal. So the ROC is to the right side of the rightmost pole, and this is the region of convergence. Implies for this signal, the Laplace transform is 1 by s minus a, and the region of convergence is real part of s is greater than a. And now for this signal, the other signal, uh, try to do the same. So it is minus infinity to 0 minus e power at e power minus st dt. And what is this? Integral minus infinity to 0 minus e power a minus st dt, which is again minus minus 1 by, or e power minus s minus at minus infinity to 0, right? uh, yeah, am I missing something again? I think this should be e power minus 80. Yeah, I think this is there in your class notes. Can somebody refer to your class notes and quickly let me know? Yeah, I think this is e power minus 80. In that case, what you have is, yeah, is that right? So, what is the other part of the signal? Do you have the class notes open with you guys? Any of you? Let me open it quickly. Mm, downloads. I think I have the class notes. So, what is the other? Okay, so the other signal is this. Um, minus e power minus at u of minus t. And okay, alright. So note the following signals: e power minus at u of t. This has the Laplace transform 1 by s plus a, and it is a right-sided signal, so the real part of s is greater than minus a. And the other signal is u of t, u of minus t. This is a left-sided signal, so its Laplace transform is also 1 by s plus a, but real part of the region of convergence would be different. Okay,
Yes, ma'am. I mean,
so
question number 12 is the answer. Please confirm the answer of question number 12. Question number 10 in graded week 12.
graded with 12, question number 10. Okay, so hmm,
Ma'am, I am getting the answer as 24 e power minus t u of t. The answer is given as 12 e power minus t u of t.
okay, but um, okay, let's do that. So question 10. So your h1 of s is 2 by s plus 3, correct? Yeah.
Yes, ma'am.
And your h2 of s is 3 by s plus 5, correct?
Yes, ma'am.
And your whole h of s, so
Mm,
h of t,
multiplication of these both.
yeah. So h of t is the convolution of h1 of t and h2 of t. So your h of s is h1 of s with h2 of s. So the whole h of s is 6 by s plus 3 times s plus 5, correct?
Yes, ma'am.
And what is your y of s? Y of s is 9 by s plus 1 minus 18 by s plus 3 plus 9 by s plus 5, correct?
Yes, ma'am.
When you do x of s is y of s by h of s. Yeah, yeah, why?
Yes, ma'am. Yes, ma'am.
For an LTI system, y of t is x of t convoluted with h of t. And y of s is x of s times h of s. So your x of s is y of s by h of s. And when you do this, what is your x of s? X of s is nothing but so if you try to evaluate this y of s completely, it will be something like this: 72 by s plus 1 times s plus 3 times s plus 5 divided by your h of s 6 by s plus 3 times s plus 5, and this is 12 by s plus 1. And when you try to invert it, x of t is 12 e power minus t u of t. That is all right, no? Yeah, this is correct only, right?
Yeah, I'm not getting 72 there.
So y of s, man, so this is 9s plus 45. Uh, so basically it is 9 into s plus 3 times s plus 5 minus 18 into s plus 1 into s plus 5 plus 9 into s plus 1 into s plus 3. Yeah.
Yes, ma'am.
So you guys can calculate this, right? Can you guys calculate and tell me like what you're getting? Others?
Ma'am, everything will cancel out. 9 into 16 will remain, I believe.
Okay. Um, This is correct, right?
Yes, ma'am.
So S square terms are cancelling out. I mean, our others are also facing the same problem with the calculation. Okay, so um,
You could just take the 9 common out and
yeah, even this is cancelling out, right? And over here, what is left is 9 times 15 minus 8 times 5 plus 27. So this is 9, 15 minus 10 plus 27, 45 plus 27, 72. Correct only, right?
okay, ma'am. I must have made some mistake somewhere.
Mm. Okay, please verify that again. Okay, any other questions? See, it's
Ma'am,
just math.
how could you write 12 by s plus 1?
Hmm?
How can you write 12 by s plus 1? Like there is a you write no 6
Oh,
divided by s plus 3 and s plus 5.
mm.
So how is
These things are
12 by s
cancelling,
plus 1?
right? No, these things are cancelling, right? This is 12.
Yes, ma'am.
I mean, this is 12 by s plus 1. What is your question? So, how do you go back from 12 by s plus 1 to x of t, or any other question that you have?
No, ma'am. I didn't notice that this upper line.
Okay, okay.
Ma'am,
Yes.
ma'am, will the recording be uploaded in YouTube?
Yes, yes. Other recordings are available, right?
Uh, yeah, I think I'm not sure. I haven't checked.
Okay, okay. Recordings are always being uploaded to YouTube. So,
Yes.
yeah. I
Uh,
mean, it's not uploaded to there is a link in your portal
Portal.
page. Yeah.
Yeah.
So it's in that sheet. The recordings are available. Okay.
Yes. And ma'am, just for confirmation,
Mm,
in quiz two, for
mm,
two questions,
mm.
was the answer keys wrong?
Which questions? There are no keys wrong as far as I remember. I think there was for one question. There's some missing variable. The key is not wrong, but there was some missing variable, and we decided to give full marks to everybody. I think Muttu, right? You wrote to me regarding one question quiz two, right?
Yeah, yes, ma'am.
No, no,
And
that answer is correct only. Like we verified
the
again with the
impulse
professor.
train.
Hmm?
Yes, ma'am. I think that's the impulse train.
Mm,
I'm not
mm,
sure.
mm. Mm, mm.
So
I think
the power is infinite.
yeah, we checked again with the professor. Yeah, that's true.
Okay.
Okay.
Yes. And ma'am,
Mm,
one doubt
mm,
regarding the thing.
mm.
Uh, so ma'am, the Fourier transform of the impulse train is also a impulse train, right?
Yes, it's
Um,
not impulse train. It's a train of the Fourier transform of impulse train. Yes.
yes, ma'am. But according to the uh, duality theorem, how can the infinite signal in time can also be infinite in the frequency domain?
Mm. Yeah. I mean, there's no restriction like. uh, that the any infinite signal in time should have finite signal in frequency. There is no restriction like that, right? Sorry, I mean I did not understand your question properly,
Uh,
but can you write to me on this?
uh, yeah, yes, ma'am. I mean, what I meant to say was, if
Mm,
some signal is finite in time domain,
mm.
it should be infinite in the frequency domain, right? Based on the duality theorem of Fourier transform.
Uh, okay, let me just
That is
write.
infinitely long.
Uh, I think that is some interpretation you came to, but I don't think that's the duality theorem. Let me open like the
Or
duality theorem.
maybe not duality. I'm not sure what's the theorem name, but in the lecture,
Can you show me like which lecture it is exactly? As far as I remember, duality is the following. So if
is it
the
like
Fourier, yeah,
the
if the
Fourier
Fourier
transform?
transform of x of t, if this has Fourier transform x of j omega, then duality theorem says that the Fourier transform of the signal x of jt is 2 pi little x of minus j omega. This is what Fourier duality theorem says. And
Yeah, so
the,
I think that's not, yeah, so what I was saying is not a theorem, but it's a rule, I think.
there is no rule like that. There is no rule like that. There is no specific property like that. For certain finite signals, so sorry, for certain infinite signals, uh, like for example, if you take the sync function, it runs across the whole time axis. But when you take the Fourier transform of the sinc function, it is a rectangular signal. So for certain infinite time domain signals, the Fourier representation is finite, and hence it's better to act in the Fourier representation. But there is no for sure rule that this should be the case. Okay.
Yeah, so that's the uncertainty principle. Yes, ma'am.
Oh, it's the okay. All right.
Yeah, so the uncertainty principle. Um, it comes little before the Fourier transform properties lecture video.
Okay. So let me just try to understand your question more better. But hold on, let me come back to that provided other students do not have any questions,
Yeah, sure.
because I don't want to exhaust the time. We are only till 8 today. So, other questions? Are there any other questions for the other students?
Yes, ma'am. Practice assignment 12, question 4.
Okay. Practice assignment. Okay. What is the difficulty that you're facing here?
In Laplace transformation.
Okay. So, the given signal x of t is t e power minus 3t plus 2 u of t minus 1. Okay, so you're supposed to find the Laplace transform. Again, you have the exponential things. So you know that e power minus 3t u of t. First, try to get out the constants. Let me call this x1 of t. So we know e power minus 3t u of t as Fourier transform, right? What is e power minus 3t minus 1 u of t minus 1? Using the properties of Fourier transform, this is e power minus s by s plus 3. In other words, e power 3 into e power minus 3t u of t minus 1 has the Fourier transform e power minus s by s plus 3. This is just a constant. So e power minus 3t u of t minus 1 has Fourier transform e power minus s e power minus 3 divided by s plus 3. Are you okay till here at least?
Ma'am, how e to the power minus s can?
That's the properties of Fourier transform. So if any signal x of t has Fourier transform x of s, then x of t minus a would be e power minus as x of s. Yeah,
Yes, ma'am.
that is what we used here. Okay. It's from the properties of the, sorry, not the Fourier, it's properties of the Laplace transform. Okay. So we use that and we get this. Okay. And then we just do some, uh, like we just try to adjust the variables, and this is what it is. But we want the Fourier transform for the following signal. Okay. And we again know certain property. If x of t has Laplace transform x of s, then t times x of t has the Laplace transform minus d by ds of x of s. Correct? Yeah. So using that, what we have over here is, yeah, and then you just try to, over here, this is minus d by ds of e power minus s plus 3 by s plus 3. Do this, and then the actual signal x of t would be, I mean, the Fourier transform of the actual signal would be e square times x1 of s, where x1 of s is this term. Is that okay?
Yes, ma'am.
I mean, we used two properties. One is x of t, if it has the Laplace transform x of s, then x of t minus a has the Laplace transform e power minus as x of s. If x of t has the Laplace transform x of s, then t times x of t has the Laplace transform minus d by ds of x of s. We used these two properties. Okay. Any other questions?
Yes, ma'am. Question it.
In the same practice assignment,
Yes, ma'am.
question 8. Okay. For this specific question, Satyam, I will ask Professor Tony to write to you via email, okay? I'm not a circuit theory person. This is something related to circuits. Okay. I can ask Professor Tony to write to you via email on this. Okay.
Okay.
So let me just write to you his email ID right away. Any other questions?
Yes, question 5 also same assignment.
Question 5. Okay. Okay. Let me get back to you. Uh, Question 5. So I sent you the email ID. Please write to Tony on the other question that you were asking me. Moving to the fifth question, what is the difficulty that you are having? So this is t, this is h of t, and then you have 0, 4, 2. Okay, so the steady state value of the output is given by y infinity, and y of t is x of t convoluted h of t. From the final value theorem, this is limit s tending to 0 s times y of s, and y of s is x of s times h of s. What is your x of s? X of s is 2 by s, and what is your h of s? So h of s can be calculated as follows. So h of s is integral 0 to 4 2 times e power minus s dt. When you evaluate this, this is e power 1 minus e power minus 4s. So this is 1 minus e power minus 4s. So your y of s is 2 times 1 minus e power minus 4s by s, right? And yeah, y infinity steady state value using the final value theorem, limit s tending to infinity s times y of s, which is limit s tending to infinity. You just have to evaluate this. This is mm, I think there is another 2 by s factor when you calculate h of s. So it's 2 by s, 4 by s square. So what happens when s tends to 0? So you have to find the limit. Yeah. So what is this? So this is limit s tends to 0 d by ds of 4 into 1 minus e power minus 4s plus to calculus. This is 1. What happens to this? This is 16. Is that okay?
Yes, and how 2 by s can
Hmm?
how 2 by s can in this?
Here, here,
Yes, ma'am. Yes, ma'am.
I do the integration. No? So integration, what happens over here? Integration is integral 0 to 4 to e power minus st dt. This is 2 by minus s integral 2 by minus s e power minus st 0 to 4, correct? Yeah, correct.
Yes, ma'am.
Hmm. Integral e power at dt is e power at by a, right? That's how the two ways came. Okay, is that all right?
But 2 by s can two times.
Hmm?
2 by s can two times.
Ah, so this is h
Why?
of s. This is h of s, right? Your x of t is given as e power minus 2t u of t. Ah, is that right? What is your x of t given? Sorry, 2 times u of t. What is your x of s? 2 by s. So one 2 by s is corresponding to x of s. The other 2 by s is corresponding to h of s.
Yes, ma'am. Okay.
Okay. Any other questions?
Ma'am,
Yes, yes. Uh,
could you scroll down a bit?
okay.
Yeah, yes. So it's a L'Hopital rule, right?
Mm-mm. You mean here, right?
Yes.
Yeah,
Yeah, the last. Yes.
yeah, yeah.
Yeah, yes.
Regarding your question, Muthu, so I'm still thinking on like why it happens, so why it fails for the uncertainty principle. Okay,
Yes.
let me write to the professor, putting you in the CC. Okay.
Yes.
Yeah, if you have no more doubts, we can end the session. I'll write an email to professor with your question, Muthu. All right.
Yes.
Thank you.
Uh, and ma'am, in next session,
Mm.
um, uh,
And what Muthu mentioned was discussed in lecture 9.4, uncertainty principle.
Yes, yes, I saw the notes. Yeah.
Yeah. Can you mark me as well on that email? I would.
I'll update regarding it in the next slide session, okay? Based
Okay.
on the reply
Thank you.
that we get. Okay?
Yeah, sure. Thank you, ma'am.
Yeah.
and ma'am, in next session, can we
Mm.
do some problems for the practice of intern?
Uh, that is something that we have to discuss with the professor because you may be needing more problems, but for the other students, we may be
No,
overloading.
ma'am,
So,
like some just from the practice and graded questions.
yes, yes, sure, we can do that.
Yes, ma'am.